I am Hosono, and I will take you through the cloud functions of photo and media storage. I'll actually run the demonstration application to give you the explanation, including the walkthrough of source code. Let me sit down to show the functions while operating the PC. My presentation will be as follows. First, I'll give an overview of the storage functions and the function configuration, then operate the actual application using these functions, and finally explain its content and important points. This slide lists the storage functions which are provided by the cloud this time. Very simply stated, this service allows users to store JPEG files to the cloud and download and use them anytime. The available functions are listed in the slide. First, users can upload images. They can get the list of images uploaded to the cloud. They can get the information about images such as file size. They can get and delete the image data itself. The overview of the function is as shown here. Only the main functions are listed here. More advanced functions such as acquisition of EXIF data are provided, and will provide more functions in the future. The functions shown in this slide are provided through REST API, basically by using HTTP protocol, which is used by web browsers, and can be used by accessing the URL shown in the slide. For example, if you write an image identifier after /media and access the URL content, the image data for the identifier can be obtained. However, when using REST API for web, the authentication authorization procedure required to support the cloud, namely the procedure to get an access token and use it to get images for secure access, is rather complicated. So, we provide an SDK that simplifies this procedure very much. This slide lists the set of JavaScript APIs, which I'll explain now. By using methods such as upload, list, info, download, and delete, the authentication authorization information described earlier can be exchanged internally without user involvement. This makes creating applications much easier than using REST API directly. Now, I'll explain the real application I created. I'll operate it later in this seminar. This application is a very simple one that allows you to display the images stored in the cloud side as a slideshow as shown in the screen. As this application uses RICOH's cloud service, I implemented a function that uses user IDs described by Mr. Takakua earlier to change the user accounts and displays images stored for each user account to take advantage of the cloud service. This slide briefly shows the three features of the application. This application displays the images stored in the cloud as a slideshow. It also supports multi-account. In addition, it is multi-platform by using JavaScript SDK. I created the application that operates on all main platforms such as Mac OS, Windows, iOS, and Android. Well, let's start the application I made. I set up a web server on this Mac whose screen I am operating now, and placed my application content in the server. This application is configured to be started by accessing the URL of this content. The URL is already bookmarked, so I start the application. On the screen, the browser is started just now. Clicking the Start button on the screen displays the images already stored in the cloud as a slideshow like this. Once the slideshow starts, the Start button changes to a Pause button. Clicking the button again stops the slideshow. In the Resume state, clicking the button again restarts the slideshow. As for multi-account function, the user ID can be switched by using this selector box on the screen. On the screen, I switched the user ID to another user ID just now. Then when I start the application, the images stored by the new user are displayed. The application works like this. Finally, as for multi-platform support, the application is created by using HTML5 and JavaScript, so it works in the same way on a smartphone screen as shown on the screen. Sorry for the small screen, but you can see the application installed on my own iPhone. when starting the application, the exact same screen appears to let you start a slideshow. When you want to immediately give a form to your ideas and operate it during this developers contest, or when you want to try your application not only on a PC but also on a smartphone, please use HTML5 and our JavaScript SDK. I hope you can realize your idea in a considerably short time. The overall configuration of the system demonstrated now is shown in this slide. The configuration is divided into two major parts, the cloud side and the Mac side, my own PC. I set up a web server on my PC side and placed the application content, HTML, CSS, and JavaScript on the server. When I start the browser and access the localhost URL, the application content is loaded into the browser, and the application starts. In addition, in this configuration, the loaded JavaScript uses our SDK, which coordinates with the cloud service to execute various functions such as obtaining images or a list of images. On the cloud side, several images are stored for each user account, and the application can switch images for each user. The program I showed you now is a small prototype I created to introduce our Cloud API, wishing to create an interesting application. Generally speaking, it's really hard to support the actual cloud, since we need special considerations, such as security issues, image acquisition method, and so on. By using our SDK, I could develop this application, which I introduced now, with about 100 lines of code. The entire application could be developed by writing only 100 lines of code, including JavaScript as well as HTML and CSS. So, if you learn 100 lines, you can create an application equivalent to this one. And if you learn 200 lines, you can create a more advanced application. I hope those who do not have experience in script language take the challenge. Now, I'll explain more detail. I will actually show the source code while I explain the operation. This slide shows the four major files constituting this application. There are index.html and HTML files, a CSS file to define the display style, a JavaScript file to control the application, and a file named RICOH API-mstorage.js. The last one is the SDK provided by us and distributed at GitHub. The numbers of coding lines shown on the screen indicate the parts I developed for this application. I wrote 41 lines, 25 lines, and 53 lines for each part, respectively. I aimed to develop the application with up to 100 lines, but actually it took 119 lines, slightly over the target number. However, I didn't intend to write code to save line count. So, this example means that you can usually develop an application with about this number of lines. Well, let's see the actual source code. Now, the screen shows the HTML file to start the application. You can see the number of lines on the screen. The first half part performs the required operations such as loading JavaScript. RICOH API-mstorage.js shown on the screen is the SDK provided by us. This SDK is loaded by this HTML file. After that, there are descriptions for arranging elements such as buttons in the image display part. That's all. The next screen shows CSS. This is to design the appearance of the screen by defining styles, such as the appearance of background images and the width of images. The code fits in a screen more or less. Finally comes the JavaScript part. Now we come to the main part of the explanation. I wrote this part in the small number of lines as shown on the screen. I wrote the code in an easy-to-see form without putting several statements together in a single line. Still, the number of the lines shown on the screen are all that are required to implement this small application. Now, I'll enter into more detail to explain how this application performs a slideshow. First, the screen displays the images of the slideshow, and those images are displayed by using the HTML image tag. Right now, logo.png is given in the image tag, and the logo of characters 360 degrees is displayed. Let me change this link to a link of another image as a demo. Now the logo changes to an icon, as shown on the screen. Or if I change it to the link to bg.jpg, the JPEG file used as a background image, the image on the screen also changes. The point is the link destination of the image tag. The application is configured to display images as a slideshow by changing the link destinations given in the source attribute. Next, I'll explain this JavaScript code. Here, two functions called event handler are defined. They are called when some event occurs and are important points to understand. On the screen, the first function is displayed. This is a handler which is called when the first application named $document.ready is started. I set a breakpoint here. So, when the application is started, it proceeds up to here and stops. When the application is started, this event handler is executed first. So the processes necessary at the initialization of application are written here. The second event handler is called when the Start/Stop button on the screen is clicked. I also set a breakpoint here. This handler is called when the button labeled Start to start a slideshow is clicked. The button is labeled Pause Now. The application is configured to jump to the same point, even when the Pause button is clicked. Then, how does JavaScript control the slideshow? The handler I explained now plays an important role. This handler is called when the Start, Pause, Resume button is tapped. When the button is labeled Start, the handler obtains the list of images stored in the cloud and then starts the timer. When the button is labeled Pause or Resume, it stops or starts the timer. The images obtained from the cloud are displayed one by the timer processing. The slideshow of the images obtained from the cloud is achieved by rewriting the link destination to display the image, which is specified in the source attribute of image tag as mentioned before. Thus, the configuration is a simple one as described above. In the application design, there are two important points for actual support of cloud. As long as you keep the 2 points in mind, you can create a similar application easily. Now, I'll get down to these 2 points. The first point is as follows. Before connecting to the cloud, the authentication information needs to be set in SDK by using SDK API. By doing so, the subsequent security procedures required to use SDK API are automatically handled by SDK, so you don't have to worry about security authentication and authorization procedure at all. This screen shows the actual source code. The handler named Ready, which I described before, is called first at the application startup. It's necessary to tell the handler whether this application is authorized by the cloud service or not. The information for this is created by using this authClient class. This program requires that a client ID and a client secret, which need to be obtained to participate in the contest, are entered in this code part shown on the screen. As for this application, this authClient object is immutable, so we just need to create this information at the application startup. Then, let's think about what happens when the Start button is clicked. When the Start button is clicked, the images for a particular user account are displayed as a slideshow. That is, the images to be displayed must be changed for each user. So, to the authClient object created before, we need to set the information about which user account should be accessed when the Start button is clicked. Before creating an instance of Storage SDK beginning with the name mStorage, create such account authentication information and set it to the authClient object. By doing so, the authentication and authorization procedures are internally performed automatically when APIs such as Connect and List Acquisition are executed. So, you do not have to worry about authentication when operating the cloud storage. Let's see the actual operation of this on the browser. I set a breakpoint at the handler for startup. When the application is started, this event handler is started. First, create an object named authClient where the client ID and client secret are specified. The log saying app started is displayed now on the screen, indicating that the application is started. authClient is generated in advance. Next, as for the process when this start button is clicked, I set a breakpoint at the event handler, which is executed when the start button is clicked. Now, I'll execute the application step by step. At this point, if the button is labeled Start, the user account currently set is obtained, and its photos are obtained. Use the authClient method to set this user account and its password. Then, create an SDK object named mStorage, which is later used to access the storage. Once authClient is set here, the authentication procedure is internally performed for the APIs such as Connect and List Acquisition. The screen shows that the List API is executed successfully. You can know it from the log in the list displayed on the log output screen. This means that the list of IDs of images stored on the cloud side is obtained just now. Then, the second point is as follows. The image data stored in the cloud cannot be referred to directly by using the URL given in the source attribute of image tag due to security concerns. There may be a service that allows such reference, but our current media storage service does not allow images to be referred to directly. This is because if images can be referred to directly from the URL, anyone who knows the URL can enter it in the browser to see another user's images. Therefore, our policy is not to allow such direct reference. Then, the question is how to design the processing, which I mentioned before, to display a slideshow by changing the content of image tag. There are several ways. Among them, I most recommend the way I showed you before in the application. That is, we convert images into so-called blob format when obtaining binary data of images. Blob is a data structure which contains binary data called binary large object. We can create a URL where such blob data is stored. By setting this URL in the source attribute of image tag, the content can be referred to and displayed. So, two steps are required: obtaining data from the cloud in the blob format and creating an object URL that refers to it. We recommend you to design the processing to display the images stored in the cloud through these two steps. Our SDK allows you to use an API to download data in the blob format. Using it helps you to implement the processing easily. I'll explain this also with actually showing the source code. The code shown on the screen downloads an image from the cloud by using the storage SDK. Specify the image to obtain by specifying the image identifier, that is, one of the IDs in the list which was obtained before by using the list method. Enter the string blob as the format. With this, the image data can be obtained in the blob format, and by using this blob data as an argument, the code calls a method named url.createObjectURL. Then, object URL is generated. This URL can be set in the source attribute of image tag. When you do so, the image will be displayed. This url.createObjectURL method is supported in the browser environment. It can be used by relatively new browsers. I'll show you the actual operation of this. On the screen, I started the application. Then, I set a breakpoint at the code to download the media storage to display the images of the slideshow. Then, let me start. The program has executed up to the breakpoint. Here, I'll specify the blob format to download the image. When the download is completed, the control moves to here. Now it's completed. A JPEG data of an image with the size of 172K was downloaded and obtained in the blob format just now. By using this blob data as an argument, createObjectURL is called. When it's called, the variable URL contains a URL beginning with blob. Set this URL to the image tag I mentioned before. I set it now on the terminal. When the execution returns to the system, the image on the screen will be updated with the image from the cloud. Please check the URL on the screen. As you can see, a URL beginning with blob is given in the src attribute of image tag, and it is continually changing each time the image is updated. This is because the process explained before is running. An image is obtained from the cloud in the blob format, and then a URL is created and set here. The URL continues to change, and the images downloaded from the cloud are displayed on the browser. This concludes my explanation of the application design and key points. Finally, let me add one more point. When using our SDK on a browser, please note the following. The SDK for JavaScript is provided as a JavaScript package named node.js, which is used mainly on the server side and not on a browser. Therefore, if you want to use it in a browser environment, you need to convert the source code. The operation of converting source code is generally called browserify. There are several tools to execute browserify operation. In this demonstration, I used a tool named Webpack to convert the source code. If you use the SDK currently published, you must perform this conversion on your own. In the near future, we plan to publish SDK that can be used as it is on a browser. I hope you use it in the future. How many applicants were there in last year's contest, and per section? For the previous contest, we had 72 applicants in total. Previously, the contest was divided into 3 sections, and each had about the same number of applicants. Last time, the contest was divided into several sections. Application section for things like APIs, gadget section, and other. This time, the contest takes submissions collectively and widely, from applications to solutions, plus gadgets. There's no specific limit to what you can submit. I may be asking a similar question, but what was the ratio of submissions of individual contestants and corporate contestants? About the ratio of individuals to corporate, there were applicants who entered as an individual but actually as a company employee. Conversely, some corporate applicants were actually individual entries. So I think it's difficult to get accurate figures. My guess is that it was almost 50-50. Thank you. Finally, let me show you the functions to be introduced in the future. The items listed on the screen are not finalized, just under consideration. We are considering such functions as remote control to click THETA's shutter as explained by Aikawa earlier, sensor collaboration, image processing, and image recognition, plus data storage and analysis and SNS linking. I am repeating myself, but these are not yet finalized. Please watch out for future announcements. As Aikawa presented earlier, this screen shows our image of the world where, for instance, the remote control function is available. The first example uses 2 single-board computers, which you can regard as small computers. We use 2 of them, the Cloud API and a RICOH THETA. The first single-board computer issues a shoot instruction to the API. Then the API instructs another single-board computer. The THETA connecting to this second computer shoots an image. All of these are realized by using the MQTT protocol, often used in the IoT field. We are thinking of implementing it now. Other than shooting, obtaining an image remotely may be realized in a similar manner. This will create other possible use cases. For instance, you can press the shutter remotely to see the image of your pet left at home from your workplace or school. That's all about it. You have learned about our Cloud API. This slide is the last slide. I'd really like you all to enjoy THETA and the Cloud API provided for THETA. Please remember that this is a global contest open to the entire world. We prepared an English website for it. Last year, a German contestant won the first prize. This contest uses the API open to anyone. Feel free just to register, try it out, and then make an entry when your work is well done. And this is important. The first prize is 1 million yen. If you enter as one person, you would take it all for yourself. Other than this, the contest offers awards of 5 million yen in total. The deadline is August 10th, just before the summer vacation season, giving you plenty of time. I'm very excited about the contest, expecting that the world generated by THETA, together with your own new world created through the use of the RICOH Cloud API, will bring a brand new perspective of the world, discovery, surprise, and even innovation. The seminar is over now. The live video broadcasting is stopped. Thank you. The video will be made publicly available. Thank you again for your participation.